Hi folks, we're going to do a little review on proving identities, okay? So here notice they give us this equality, but they tell us we have to prove that this is true. So we can't assume that it's true. So the way we're going to work with it is we're going to start with one side of the equation and manipulate it until we can show that it has to be equal to the other side of the equation. Okay, and if you remember the sort of trick that was given for starting these identities is to look for the side which seems a little more complex. Okay, because a more complex side means there's more algebra you'll have at your disposal to work with. So if I look here, this definitely seems to be the more complex side. So I'm going to call that the left-hand side. And you'll notice here I'm not going to have the other side of this equality as I go along, because I'm trying to show that this is equal to that. So it's just a recap of the type of manipulation that you can do based on what you learned in grade 11. Okay, so the identities that you would have definitely seen back then is you would have seen that tan of theta, which of course can be defined with x, y, and r on a Cartesian plane. You saw that it was equivalent to dividing sine theta by cos theta. Okay. Of course, you have your reciprocal trig identities that cosecant of theta is just 1 over sine theta. Okay, secant of theta is just equal to 1 over cos theta. Okay, and then you have cotangent of theta is just 1 over tan theta. Okay, now the other ones that you would have likely seen would have been what we call the Pythagorean identities. Okay, so the one that is most commonly used is sine squared theta plus cos squared theta is equal to 1. Okay, there's a couple of others, but the most popular one, I guess, besides this one, would be 1 plus tan squared theta equals secant squared theta. Okay, and this is basically all you have at your disposal in order to prove these identities. So this is all the algebra that you can use. Okay, so let's start with this left-hand side. Okay, now another thing that you might want to do as you're working with this left-hand side is always keep an eye out on the right-hand side. Okay, as I notice here on the right, I'm trying to come up with something that only has sines and coses. So my first thought is, well, let me just change these tangents into sines over coses. So this is sine theta over cos theta, okay, plus 1 over sine theta over cos theta. Okay, and so here, nothing I can really simplify here. But on this one, I can do some simplification because I have 1 divided by this fraction. So we know that dividing a fraction is the same as multiplying the reciprocal. So this is equivalent to 1 times the reciprocal cos theta over sine theta. Okay. Now, just to show you that you can solve these things in different ways, or you can prove these things in different ways. Say when I saw the 1 over tan theta, okay, I could have right away replaced that by cotangent of theta. But since cotangent of theta is just a reciprocal of 1 over tan, I could have then written that, well, the reciprocal of tan, sine over cos, is just cos over sine. Okay, so sometimes you might see two people proving an identity and the solution doesn't look exactly the same because there's often more than one way to get to the answer. Okay, so now there's nothing else we can do with the individual terms, so let's add these up, and we can add them up as though they were rational expressions. Okay, so I'm going to have a common denominator. Well, I'm going to need both of these factors, so my common denominator will be sine theta cos theta, which I'm very happy about because that's the denominator I have on the other side. So here I have cos, I'm missing sine, so I need to multiply sine theta by another sine theta, which we can represent by sine squared theta, plus here in this fraction I have the sine theta, I'm missing the cosine theta, so I'm going to multiply the numerator by cosine theta, which is going to give me cos squared theta. And now here I realize that, hey, sine squared theta plus cos squared theta, I can now access this identity, so that's just equal to 1. And lo and behold, what have we found? That this is just equal to the right-hand side. Okay, and so the identity is proved. Okay, so again, let's recap. Number one, you can only work with one side and manipulate it. Now you are allowed to manipulate it, stop at a certain point, and then work with the right-hand side, but it must be done independently. You can't work with this equality as an equation because you don't know yet that it's equal. Okay, number two, the only thing you have access to are the identities that you would have established up until this point. Okay, so don't make up, it's just the same way as you don't make up algebra with logarithmic expressions or rational expressions or polynomial expressions. Don't make anything up with trigonometric ones. Okay, so there you have it.